Gentlemans, men's. We're all here today because we want to work on an amplifier. There's no Fat Cat logo on this, but this is a Fat Cat 2x8 that was sold to this guy underneath the idea that it had sideband in it. Well, it's got a sideband delay, that's for sure. A little preamp, we'll operate, we'll stand by. Nice carbon fiber rocker switch, little variable on the front. Let's go down in here and let's take a look on the inside of this beautiful thing. I will say this, his solder work is top notch. Yes, sir. As we go forward in this little process, I need everybody to keep in mind and their mental capacities in check, and remember that my job is not to, nor would I ever, talk shit or give anybody any crap. That's not my job. My job is just to fix the amplifier, right? And document what I do for the end user. So the first complaint the customer had has to do with the lid. As we see these holes, what he was attempting to do is shove more air through the amp. These little fans don't move enough air to adequately cool this thing. They don't now, nor will they ever, right? So his idea was that he would drill some holes in it, and then he had a fan that was pushing air in, and it didn't work out too hot. So he went in and he covered those up with some duct tape. We're not going to worry about that. We are going to change the fans. We're going to put some higher flow fans on this. And I was like, dude, listen to me. When we get going, when this thing is done, we're going to move some friggin' air through this thing. He's like, okay, cool. So we know that now going into this, so we can go back over and we can focus on this. Let me move the lid out of the way because we're not going to need to look at that for a hot minute. First off, let's identify what we have here for supplies. These are megawatts. This is the S-400 series, and there's 4 of them in here. So if I was to be generous in their rating, right, and this is the first thing that caught my attention, that, and I believe one of these modules is smoked because it stinks like there's no tomorrow. We'll get to the bottom of that. If I was to believe the label on the front of this thing, they're claiming these are 36 amps apiece. So 36 times 4 is 144 amps max output, right? Max. Well, here's the problem, is that's feeding 8 transistors. And as we all know, and this is a common across the industry accepted thing, each transistor pulls roughly 25 amps worth of load peak. 50, 50, 50. There's 200 amps worth of load on 144 amps worth of supply. So maybe if we ran sideband or AM and loafed it, maybe it'd hold together, maybe it wouldn't. I'm not going to go down that rabbit hole. This is a 30 amp Xinjiang Wang Dong Long Shlong Ding Dong Ting Tong Wing Wong power supply, straight from Chinesium. It could be 30 amps, it could be 10 amps. We have seen that China has been putting out supplies that are supposedly 40 amp or 30 amp, and when we actually load test them, they hold 15 or 20 amps. So we don't really know what this is. Totally combined, we'll be generous and we're going to give this a 30 amp rating. Okay, there's 174 amps worth of supply inside this cabinet. There's 250 amps worth of load. So at the driver's section, 2 2879s, driving 8 2879s, fully loaded, like maxed out peak load, there's 250 amps worth of current consumption with a power supply that can put out 174 amps. This one supply is set up to power the 2-pill section. These 4 supplies are set up to power the 8-pill output section. No. I have no problem with the megawatt supplies. They are exactly what they claim to be most of the time. I have had several of these where they have failed, and they have dropped 200 and something volts DC or 300 and something volts DC directly onto the positive rail and fry everything they were attached to. So I kind of shy away from using these. But once again, it doesn't really matter. I mean, it doesn't matter. We don't have enough supply here to adequately feed the output section. So we've got this single doorknob, which I have a hard time believing is spot on the money for the output tune. It's okay, we'll add a capacitance tube here. There's a single electrolytic. You never attach electrolytic to... There's not enough capacitance to choke off the field RF that could be present on the back of the transformer. That's why we add so many disc capacitors coming off this distribution bus, and then we use electrolytics to help supplement the voltage ripple that takes place in between your modulation pulses. What we're going to do here is we're going to put a different power supply in this, and we're going to bias it for sideband, and then we're going to go through and we're going to check it out. So I told the customer it's going to take me a day or so to pull this completely apart, and then a little bit of time to put it all back together, and then a little bit more time to retune everything. He said he's had multiple transistors fail. He said that this box quit on him within a day. Now, I say that carefully. And listen to me when I give you the definition of my term carefully. Just because somebody gets an amplifier from their builder and they say to me, oh, it died within a day, that doesn't mean a whole lot to me. Being a builder, I understand that there are people out there that don't maybe quite grasp how to use their equipment, and I'm not saying that's the situation with this guy, and I'm not saying that's what he did, and I'm not trying to shed any light onto the builder in a negative way. I'm just saying that I was informed by the customer that it lasted a day. He's gone on and bought himself an antenna analyzer, and he's got himself multiple meters, and everything is telling him on his side of the street that basically his antenna setup, his coax, and all that stuff is right. So we have to assume that something caused this to quit within a day. It blew up some pills. It's been back to the original builder once or twice. We've heard all this song and dance before. Long story, short story long. I personally don't believe there's enough power supply in here to do the job safely. Just saying. So we're going to put a new power supply in here. We're going to use some of these. You guys know what I'm going to do. It's going to get a bunch of 100 amp modules. We're going to probably put 3 of them in here, which will give us 300 amps worth of peak power. 300 amps worth of power supply to be able to feed the amplifier section. So we're not going to be running out of juice. The other thing that I caught wind of was when I was talking to the customer, he informed me that what was happening is he'd key down and the fans would almost stop turning and they would go incredibly dim. Well, the fans are hooked up to this front supply, as we can see. That was telling me either there wasn't enough shmoo coming from the wall outlet, or the power supply itself over here was dipping down so hard that it was causing the fans to stop. Usually what will happen is some RF will get in the fans and it'll cause them to quit spinning, but the diodes on the fans, on those backlit fans like what are in this thing, they won't dim. So when we see the lights dim, that tells us right there, right out the hop, that there's not enough power supply shmoo to handle it. The other thing is this guy loves sideband. As we all know, we do not ever want to run a Class C amplifier or something where the output transformers are directly choked to ground. We do not want to run that on sideband. At the end of the day, that ends up causing all kinds of problems. Just going to say that. So we're going to add some bias to this, rebuild the power supply, probably change the output tune a little bit. Farts around with this. We're going to look at the input tune. We're going to add a little bit of a padded attenuator on the input. Not much. We're going to trim off some watts. The radio that this guy wants to run with this amplifier is directly designed to do, I think, 1 or 2 watt dead key, and the max is 50 watts peak. Which, with this variable, the only way he's ever going to be able to run it is with the variable all the way open, because if he runs it at any other stage, that amount of RF is going to cause this potentiometer to burn up. So we're going to take and bleed some of the RF off as we go. Sorry, my mind kind of drifted there for a second. I'm sitting here looking at this output relay setup here. So RF comes in, it goes through relay. This relay is tied in parallel to this relay, so both relays fire. So RF comes down, goes through here, up to the variable, out the variable to the 2-pil section, out the 2-pil section, then back down this piece of coax, comes back up, runs up to this portion on the relay, over here, comes out of the relay, goes to the big relay, goes through the big relay, comes back down, comes around, and it goes over here to the input circuit. Ah, it's interesting. Well, we could do that so that you could make it so that, like, we could add another switch and just drop the 2-pil section completely out of the box. The preamp is on this relay. So preamp off, RF comes in, goes through this relay, relay off, transmits, goes through this relay, comes back down around, goes down, goes through this connector, goes back up through the relay, goes across here, comes back down and goes out to the antenna. But it's in reverse, so the RF comes in that we're trying to preamp. It's interesting that they would use 2 relays. I wonder if this amp was built for a different purpose and this ended up getting sold, and oh, that's interesting. That's interesting. Okay, so the first things first is we're going to take this out. We're going to get rid of all this. We're going to snatch it up out of here because we're going to do something different here when we go to put our other supplies in. So first place to start, right here. Okay, so I'm back on the Fat Cat project. I had to stop for a few hours. I had to look at a Meritron AL1200. One of my local guys. He just didn't understand how to tune it. Okay, so as we've covered in many YouTube videos before, when you use a mobile cabinet box like this, you're going to end up having a gap back here. Now, I'd like to say, oh, it's left wide open. It is not. Believe it or not, there's a clear piece of plastic that is down here. I don't know if you guys can see that or not. The problem is it's held in with silicone, and the silicone is not holding on to the plastic anymore. Like, here's my finger. The plastic is completely bent, and it's just letting all the air rush right out of the back of the cabinet. There's another small problem that I've noticed here, is there's no physical attachment to the case over here. And how I figured that out was the solder tab that's back here in the corner for the coax connector is broken off. And I thought, well, that's an odd thing, because you have an attachment here and an attachment here and an attachment here. What would cause the board to tilt and rotate up? This would. The amp was held down with glue. So we're going to add a reinforcement. We're going to use some long 632. We're going to go here. We're going to go here. We've got to support the board. And as far as this goes here, I'm going to have to dig this silicone out of here, probably cut it out, And we're going to replace this with a hard piece of phenolic, so we don't have this low air pressure pocket here. If we don't replace that with something that's stiff, that won't move, what little air that we're going to be able to push through this cabinet, or what, pardon me, let me rephrase that. What little air was being pushed through this cabinet just runs right out this hole, instead of going down the heatsink and out the back of the amp and actually cooling anything. So the other thing we did in the progression of things is we modded up 4 supplies. Now if we were running this on 220, we would need just these 3 modules to be safe. But since we're running this on 110, and as we all know, the 110 volt side of these power supplies, they drop in their output. So to be in 100 amps a module, usually works out to be about 120 amps per module, 100 amp per module, and then we run into, okay, it drops down to about 70. So 140, 140, for, you know. So we need 250 amps minimum to make this work. Well, we're going to give it 280. And that just about maxes out your, I mean, it totally maxes out, by the way, your 110 volt outlet. The beauty with these modules is that they're automatic internal switch 110, 220. So if the guy, when he gets this back, my customer, wants to rewire this plug for 220 volts, he's going to get much better performance out of these modules. But all he's got to do is change the plug. Doesn't have to physically open the cabinet to do anything. So we're going to modify this and get this all set up so that it's ready to receive these power supplies. Once again, it's the beauty of these switchers is we've determined that this is roughly 170 amps of supply, right? That's the same amount of power supply, actually more. Because we put this on 220 volts, now this is 200 amps, versus these still just being 170 amps worth of module. And I'm going to say this module is toast. It turns on and lights up, but you can sit there and watch the DC voltage and it fluctuates a bunch. It's flip-flopping around between, I think it was like 11 volts and 15.5, and it smells to holy hell. Like when you plug it in, you can smell something physically burning. So this is probably a good thing that we're replacing these 1,000 ways from Sunday. Okay, let me do some more work. Get the silicone out, power supplies in, and yeah, let's get on with this show. All right, well, moving along here finally. We got rid of the clear pieces of plastic and we replaced that with a solid piece of phenolic. And then we took 2 pieces of 632 and we threaded those down. So now the amplifier is fully supported. Actual board itself, let me move you over here where you guys can enjoy this. Redid the positive and negative wires on this thing. We stretched the negative wires out, so we're making contact along this edge of the board, and all the positive power wires go out here. We piggybacked off the 1-pill driver. The reason we did that is so that not just one power supply is going to see more load than the rest. We want to spread that out. Okay. Now, this is kind of a cautionary tale. There's your 511 picofarads on the input transformers, but only 1,000 on the output. And if I remember correctly, because these are 2879Cs, if I remember correctly, that's a little low on the outputs, and I'm not a big fan of this doorknob, and I want to change the inductor. The other thing we got going on is we got 1 or 2 of these transistors are getting a little bit hotter than the rest as we're running it. Let's go ahead and we'll turn this on. So we power up, and I had everything set at 15.3. Oh yeah, hey, why I got everybody here? I want to show you this. This is normal. This has been perplexing people quite a bit on the internet here lately. Let's tilt this up where you can see it. You'll see that all four of the indicator lights, I want you guys to see this. They're all off. We'll turn the amplifier on. They're all going to power up. Now watch. Give it a couple seconds. They figure it out. These things are smart supplies, right? So this is the primary load, but then they're all on, just the indicator lights are shut off. They've been doing that since the very beginning. They'll figure out one that's going to be the control module and the rest are going to be paired to it. So, just saying, don't think you have a problem if you build a multi-pack of these supplies. Shit's going to turn on, all the lights are going to kick on, but only one of them is going to stay consistently on. Watch. Bloop. Okay. So we're good. That's good stuff. So let's come over here and let's run this thing here real quick. And I'll show you what we got going on. We got this in standby at the moment. So we're at 15.3 on the power supply. Variable is all the way open. The one thing I want to change, one of the things is I want to put a variable capacitor here. We're going to put a variable capacitor here, right here. We're going to change this. I don't like this. I don't like this either. We're going to change how that's done. I mean, it kind of makes electrical sense that way we're not asking everything to make a hard 90-degree turn. Because we're going to take and twist this. We're going to build a whole new inductor coil, but we're going to see how this runs. We're just going to run it now for now. So this is a 1000 watt slug in 5X. Okay, so as we all know, when we're in the 5X mode, we're reading that middle scale and we're adding a couple zeros. The middle one's a 1000 watt slug in average, and then a 5 watt slug in reverse back from the Bird 10,000 watt dummy load. We're going to show you the amount of drive. We're just putting like 18 watts in this thing. Hit 0 and 2. Let's take this down to 1X so you guys can actually see it move around a little bit. Hit 0 and 2. 15 to 18 watts. Go back to 5X. Put the amp in operate. Hit 0 and 2. Hit 0 and 2. Okay. So we're seeing 2300 watts. To me that seems a little off and a little low. Hit 0 and 2 and 2. And we'll say this. The input tune up here. Hit 0 and 2. It's pretty good. Pretty good. Let's check our variable. Hit 0. The variable is working. Let's take a look at this. Here's the radio. Hit 0 and 2 and 2. Here's the amp and dead key mode. Hit 0 and 2. That kind of bugs me a little bit. First, second, third, fourth, fifth order harmonics. It makes me wonder. Let me turn around and look behind me here. Hit 0 and 2. Yeah, I wanted to see what it looked like on the radio behind me here with the waterfall. Didn't look too bad. I want to modify this. I want to modify this here. We'll probably put the tuning tube back up here on this back wall. I want to modify our inductor. And I think the guy, I got to tamping this down because these are 2879Cs. Pardon me, these are 16 DO8s. This would be the capacitance, the input and the output capacitance that we would use if we were using 16 DO8s. And we would be getting about 2300 watts. But these are Cs. Completely different mix. So, needless to say, I think we're going to be in here adding some capacitance and adding some capacitance, but I got to check my notes on this. The other thing I want to do is I want to add a switch, another switch on the front end of this thing. Since Fat Cat was kind enough to wire this up so that we could drop the driver's section out, and that's what this other relay does. I don't know. I have a feeling that this is kind of like a hodgepodge box. And what I mean by that is it was designed to be 2879 16D08s, and for some reason C's got slapped in there, nothing else got added. And initially it was wired up and built so that it would have the driver's section be dropped in and out. And don't forget, we still got to add bias to this box yet. So all we've done so far is get the power supply upgraded to the point where the voltage doesn't fall completely on its face. Using his voltmeter on the front, hello, audio, 15 volts solid, which is perfect. You want this to stay even a little bit more stable, convert this over to 220. Okay, let's let all this bleed down to 0, and let's modify the input and output network and change capacitance values. Let's see what happens. Okay, so new inductor coil, different capacitance, new output inductor coil, variable capacitance. And oh yeah, down here in the front, it's now got a second switch. So down, I'll put labels on this. Down is straight 8, up is 2x8. So we'll turn the power supply on, or turn the amp on. Make sure you guys are straight on the bird meter. We're in 1X at the moment, so turn the amp into standby. Hello, 1 2 1 2 1 2. 20 or so watts in. This is straight 8-pill mode. Hello, audio, 1 2 1 2. Here's our input tune, straight 8-pill mode. Hello, 1 2. Hello, 1 2. Once again. Hello, 1 2. 600 watts. So now we engage the 2x6, the driver section. Nails it in the corner. Up to 2x. Hello. Nails it in the corner again. Down to 5x. Hello. Hello. 2,500 watts. So it makes 2,500 watts my way versus 2,300 watts. Now we're moving in the right direction. Okay, solid power supply. This is taking forever to get this done. Solid power supply and the input and output networks are correct. And we've got it now switchable stage. So the reason this is important to the end customer is because his radio does 50 to 100 watts, he says, or 50 watts if I remember correctly. Now he can just flip this switch down and he can run it in any mode he wants. He can even put a 100-watt radio in this if he wants to, with this switch in the down position. If you run it in the up position, it's going to launch everything right out of this box. So, yeah, 30 watts, 30 to 40 watts max peak envelope in the up position, up to 150 watts, I'd say, drive in the down position. Okay, so now the last stage of this process. Oh, and I had a couple of the transistors that were getting really hot, and the reason was they weren't screwed down all the way. Saying. All right, last step is that we add bias to this thing. We'll put bias in this is going to wake it up even a little bit more. I think that we'll probably be in the 2600, 2700 watt range, if that's the case. So now let's go construct bias, which means yet one more relay. Woo! Thank God this thing's got a big ass transistor back here. Let's see here. I know I'm forgetting a step here. The preamp, I got to rework the preamp. That's it. Because when the preamp's engaged, in the 8-pill mode, I got to move the wires from here to here on the preamp, so that when the thing is in 8-pill mode, this becomes our pass-through tuning, and then this connection gets broken in 8-pill mode. Have faith. One more relay, move the preamp leads, then we're good. Okay, let's see. I think I got everything where I want it to be. This is done. I got to squirt a little bit of clear on this. That serves two purposes. One, that it keeps the amp from corroding, and two, because the fans sit right over the top, that little bit of paint sometimes can be the difference between something shorting out and something not, and that's from particles of shit falling in the amp. So I'd rather squirt a little bit of clear on here and go away knowing that I put maybe a little bit of a seal over things. I mean, electrically it doesn't provide that much insulation, but you get what I'm getting at. Got the bias all added. Everything's locked down and tuned the way it needs to. I feel very confident that this is going to go on and continue to live its life at another place, and the guy's not going to have any more problems with it. It is more set up for a 16 D08 transistor. So to the guy that owns this amp, if you end up having a problem in the future, being that you are the kind of person that can change your own transistors, I would not invest the money in putting the less stable, not as safe, not as tolerant transistor, the C's. I'm not a big fan of them, never have been. I would probably really stay secure in my suggestion of saying that you're going to need to put 16 D08s in here and you're not going to have any problems, okay? But as it stands right now, you're not going to have any problems either way. Added a bias, got the preamp all set up. Remember I told everybody, trust me, and all I had to do was move the bias leads over. That's it. And I moved our pass-through tune over to here. That's all done up. The whole inside of this is all zip tied and locked down, the whole front of this thing in here. It's all done up nice and neat. So it's all set. This thing is ready to rock and roll. Let me back off a little bit so I got room to operate the amp. We're going to use the 2950. This is our absolute test. We're seeing about another 100 and some watts out of this thing. So first we're going to start off in the 1,000 watt scale. Let's zoom in over here. So nothing has changed. It's still 1,000 on the far right there in peak. 1,000 in average 5 watt silicon reverse. You've heard me all say this 1,000 times. So hello, 1 2 1 2 1 2. Hello. That's our drive that we're putting into it. About 15 watts or so. And like I was explaining to my customer earlier today, I'm going to put a label on this for you. It's going to say 2x8 and then 8 pill. Okay. Put a label on here in a little bit. When you click this on and this switches down, so now this is an operate, we're operating in straight 8 mode. Okay, so we're just utilizing the 8 transistors on the output side. Hello, 1 2. That's with 18 watts of drive. So we're seeing 400 and some watts output power. Now we're going to engage the 2x8, so now we're going to engage the driver section. And that's from 1 watt carrier, we're throwing a 200 watt dead key. Sensitive. We'll go up to 2x. Walk all the way around the camera for you guys. 800 bird, which is pretty good, and well over 2,000 watts peak power. So let's go ahead and let's measure this again. Now we're going to go to 5x. So reading that middle scale, adding a couple zeros. So 10 is 1,000, 20 is 2,000, 30 is 3,000, and so on. Let's get in here because we're going to have some needle chasers watch this video. I just know it. Hello, 1 2 1 2. All right, so we're seeing 2,400 watts. You guys are like, well, that's not a big increase. Right. Let's look here. Our drive voltage is at 12 volts for our radio. Let's turn on a big switcher. Let's bring that voltage up. We'll reach over here, we'll put ourselves back in 1x, and we'll start over. So now, we're going to put like a whopping 25 watts of drive in this thing. Let's go ahead and shut this off, put the amp in standby. Hello, audio, about 28 watts worth of drive. So we've added 10 more watts to this situation. Remember, now we're in 1x, okay? So here we are at straight 8 again. Hello, audio. Hello, audio. Hello, audio. That's 800 peak. And I don't care how you decide to look at the meter. If we want to slide over here where I'm standing. Hello, audio. Hello, audio. Okay, 700-ish watts peak. But that's with 25 watts of drive. Whew. Okay, so now let's bring on the 2x8 section. So we're now putting the 2-pill section in line. Hello. So I don't actually end up damaging the meter, we'll go to 2x. Hello. Laid in the corner hard. Now we'll go down to 5x. Hello, audio. Hello, audio. So us biasing this thing for sideband added another 100 watts to it, is all I'm getting at. Now it's a solid 2500 watt box. Relatively clean, solid 2500 watt box. So, needless to say, here we are 10, like 5 or 10/6 of 2023, about a year later, and we've completely overhauled this thing. So, needless to say, the only thing left to do is fans and label on the front of the box. I think I should quit talking and go do that now. What do you think? Yeah, oh yeah, yeah. It's like 4 times the amount of air you were moving through here before. I toyed with the idea of putting on super high flow fans on here, and we reach a point where we can't cram any more air through the cabinet. So, hello, 1 2 1 2 1 2. Hello, 1 2. Audio. Nice and steady. Hello. 15 volts, rock solid. On a committed, keep this in mind, a committed 30 amp 110 outlet. Hello, 1 2 1 2. Audio. 1 1 1 1 1 1. I don't trust the 2879Cs. There's some guys out there that are having really great luck. There's a lot of guys that have had an awful lot of problems with them. To me, they're not that stable of a part. Hello, 1 2 1 2 1 2. Audio. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, audio. Hello. Show them to me. Show them to me. Show your swingers to me. Your hangers, your floppies to me. Hello. I'm gonna say I'm a guy. I like them all. Ron White said it best. We like them all. God, it feels good. It's good airflow. Hello. 1 2 1 2 1 2 1 2. Hello, 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 hello. Hello. 1 2. Hello. 1 2 1 2 1 2. Audio, 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 audio. I'm done. I'm done with this. Gentlemen, big shout out to Siglent, Penta, XS, Bird. Penta has given me the hookup this last week. I've made more dudes happy with Penta Labs. I'm just saying. It's been a good week for them, through me, and I can't wait to work on some future upcoming projects. Gentlemen, we're done. Labels, cleared, fans, new power supply, new power distribution network, sideband bias, retune, new output network, new 8-pill input network, new 2-pill tune, variable adjusted and upgraded. There's not a lot left to do. There's just not. I'm tired. This has been a long week. It's only Wednesday, I think, at this point. Thursday at this point. All finished. Brother, I appreciate you sending it up here and waiting forever for me to be able to look at this. I've got 1 or 2 more fat cats I got to go through before I'm done with the ROs for this year, and there's quite a few more that I think are waiting in the wings. Put that in standby. Fat Cat 2x8 rebuilt. Done. Boom diggity. I'll see you. Click, click.